is to go through this problem in chapter 8, which is, let's see now, which looks like this. So it's a beam with a given 1 inch by 1 inch square cross section, and there are some dimensions here. But on purpose, I don't want to do it with as a sketch. I want to do this thing as a sketch. I'm going to do it as a wireframe because it's good to know, what the difference is. Okay, both of them will work, but on purpose, as it's done in the book, I'm going to do it as a wireframe. So now this top point is clamped, and the bottom point is given a certain displacement. I don't exactly know what it is. We give a displacement. What we want to know is how the thing deforms, and also what is the force needed to achieve that particular displacement. There is no planar symmetry here because the top is clamped and the bottom, a downward force or downward displacement is applied. This is not, the horizontal line is not the planar symmetry of the beam structure. All right, so let's go ahead and look at here. Let's start with a part file. There we are. Okay, and then we create these 5 points in space. The 5 points, the coordinates are given to you on I think page 2. So let me see. So let's start with this first one is coordinates 301.5, 301.5. Okay. All right. Another one. Let's see now. The other one is 001.5, 001.5. I have another one which is minus 1.500, minus 1.500. Did I do this thing right? Yeah, it looks like it. One more, two more actually. 30 minus 1.5, 30 minus 1.5, 30 minus 1.5. Okay, I need one more here, and what was that? What's the coordinate of this? Let me see for a second. And I want this thing on the other side, so the only difference is that the z is minus 1.5. Okay, so 0, 0, minus 1.5. So let's do another one. 0, 0, and minus 1.5. Oops, where is it? Something is missing. Let's check how many points we've got. 1, 2, 3, 4, 5. This is the first one, that's correct. This is the second one, that's correct. Okay. This is the third one, that is correct. That's this one, fine. But this one doesn't look right. Oh, yeah, the minus. I want minus here. That's what they're sitting on top of each other. Very good. So these are the 5 points in space. And now we're going to create our lines. So create a line between this point and that point. And another line between this point and this point. And I want a circle between these 3 points. So where is a circle? Let's find out. There's a circle. See that? Circle. It's going to ask you a couple of things. It says, well, what's the method that you want to use to create that circle? Well, I want 3 points, right? 3 points. 3 points. It says, okay, what are the 3 points? Well, there's this point, and that point, and that point. Okay. And then it says, what is the support? Now, the support is obviously this plane. Okay. There we are. All right. Excellent. So let's save this thing. File, save management, save as, desktop, new folder. Okay, what's the new folder? It's chapter, how about chapter, from chapter 8. Chapter 8. Put the stuff in there. And all we have is a part right now. Okay, now the next thing is you should join these. You should join these things. And the reason you need to join it, it makes our job easier later on when we mesh it. When we mesh it, if we join them, there won't be a duplicate node at the interface. Okay? So otherwise there will be duplicate node, as I indicated in the video clips, subtle issues on cantilever beam with a load pointed at the center. You have to fix that. Basically not inconsistency, but it's duplicate node at the interface. So let's join it. Here, join. This is not a sketch anymore. This line, and that circle, and this. Join them. Okay, good. And apply material on it. Let's make it out of steel. Where is this? Steel. So metal, scroll down, get the steel, and apply it on the part, and then close it. Very good. Save it. Okay, now we're going to go to generative structure analysis. I'm not going to go to advanced meshing tool, which is just a fancy meshing technique. I'm going to go to generative structure analysis. All right. And what you want to do is you want to mesh this. The only reason that all three of them are done at the same time is because I joined it. And I use the default size. Now I don't know what is it. This is 1 inch. So maybe actually I should make these things smaller, because remember the radius of this circle is about 1.5, if I'm not mistaken. So let me make it maybe point 2. Okay. And then we can look at the mesh. There we are. So you can see that there are node numbers, element numbers, etc. Now I have a word of caution here. And that is the sole purpose of these points was to create the wireframe. If you put a clamp on the point, on this point, you're gonna have a problem. Okay, so or if you put a load on that problem on that point or this point or that point, you're gonna have a problem, because you think you put the load on the structure, but that you put it on a point, and point is not, in this context, is not a finite element entity. So let me hide these. I strongly urge you to try to not hide it, and later on when you put assembly or when you put the restraints, put it on those points. You see that it's not going to run, or in some situation it may give you zero stress because the thing doesn't see the load. Okay, this is just so that I don't make a mistake. Hide, and hide. Okay, now we already meshed it. Let's give it a cross section. Now notice that the cross section, I set the square of dimension 1 inch by 1 inch or something like that, maybe half an inch by half an inch. It really doesn't matter. So here, when I do this and I say, okay, the cross section is a rectangle, and I say, okay, the cross section is a rectangle, maybe half 0.24. Let's make it yeah. So 0.2 up and 0.2 to the side. The cross section is 0.2 by 0.2 inches. Now notice that I cannot close this. If this was a circle, I could close it, because it's asking for an orientation point. Now orientation point, we discussed about it in class, is not quite randomly done. It's not actually, there's nothing random about it. But what you need is a point that I can't create here. So let me cancel this for a second. Go back to my part, which is back there, and create a point with coordinates 0, 0, 0, which is right there, and go and use that as my orientation point. So you click on the 1D property. I want a rectangular one. We agreed on the size, 0.2, 0.2. I don't think this is the same. These are same numbers that are in the book. Probably it's 1 inch by 1 inch there, but that's okay. But Well, you know what, actually, to show you, maybe to show you, exaggerate and show you the cross section, I will make it one by one. Okay, there we are. And the orientation point is this point. And of course, the support is that thing that we joined. Right there, you see? You see? This is the way I want my beam to be. Now, if you want the, you may want a different orientation point because this is not quite like that. That's my problem. All right. So we say okay. Now the top is clamped. This top point is clamped. We already told that. And you apply a downward displacement of 0.01 inch to this bottom point, 0.01 inch in this, at this bottom point. Now remember, in CATIA, when you apply a non-zero displacement, it's called enforced displacement. First you have to make it zero, give it a zero displacement, and then change it. So here is the user-defined restraint. So to this point, I give it a zero displacement in direction Z, which just happened to be the correct box that was checked. And then I can change it right there. See that? Enforced displacement. See this? Enforced displacement in the load toolbar. And you select that, this restraint that you put in there, the one that we just did. See? I'm picking it. And then you give it anywhere. So it just happened to have the right number also from last year, maybe. Minus 0.01 inch. Okay. I think my CATIA went in coma. It's going to come back. Just give it 1 second. I've got to get a new computer. Oh. Believe me, it's going to come back. Oops, did it come back? Yeah, right there. Okay, so first of all, save everything. File, save management. This is the analysis file. I want to put it in that same folder. Once again, I sound like a broken record. On the exam, you not only have to give us the analysis, the part file, you also have to give us the analysis file. In the case of a single part analysis. In the case of an assembly that we're going to do later on in the course, you have to give us the product, all the parts, and the analysis. Let's run it. There we are. Put the view, select the front view so that we can see what happened here. It's easier to see it in the front view. Oh, not this one. Maybe side view. It's a side view. Okay, there we are. And look at the deflection, deformation, and let me move this thing up so that you can see it better. Because of the graduation, the color graduation here to lighter color, it's hard to see what's going on. Okay, so animate it right there. If you want, you can exaggerate it so that it can be spotted easier. So let me make this thing 60. Oh, look. Okay, so animate it. You can see that it's going down. That's the way it's supposed to be. If you want numbers as far as the displacement, this is what you've got. And once again, let me change the scale here, make it, I don't know, 60 or 100. I'll do the same scale as before. There. And then you can, just look right there. The maximum deflection is slightly bigger than 0.01 that I applied, because that 0.01 was the downward displacement. What you see here is the magnitude of the displacement, which has component in the x and y directions also. Nothing in y, but in the x direction. Very small amount in y. Here you can see the 0 in y. You can see that. All right, so I can't show you the. As I said before, I can't show you with my computer the average ISO graph because this is all wrong. It cannot be like that. This should be all red and then gradually should go all the way to blue. All right, that takes care of chapter